레코딩 하는 거야? 여러분들?
Professor Un Chul Sin, Professor Emeritus Incheon National University, and the immediate past Vice President of International Soil Mechanics and Geotechnical Engineering. Professor Sin improved upon various technologies for application in geotechnical engineering. Recently, he is working on honey cell modular block technology, and we have been students together in Southern Illinois University when Professor Das was the head of the department, and we've been inspired by him to work in the field of geotechnical engineering and giving or imparting various technology for the foundation engineering construction in various projects around the world. Professor Sin is a fine gentleman and traveled far and wide to propagate geotechnical engineering in various parts of the world, including India, my home country. Thank you, Professor Sin.
Thank you very much for your kind introduction, Dr. M.Das. This is a special privilege for me to introduce Professor Braja M.Das. Dr. Braja M.Das is currently Dean Emeritus, College of Engineering and Computer Science at the California State University at Sacramento, USA. He is an author of Principles of Geotechnical Engineering and also Principles of Foundation Engineering up to 10th edition. And also he wrote more than 10 books related to the civil engineering, particularly in geotechnical engineering. Since Carl Terzaghi presented the bearing capacity formula for shallow foundation in 1943, and Professor Meyerhoff also presented the general equation in 1963 for shallow foundation with the consideration of the load inclination and also embedment depths of the foundation and the shapes of the footing. In the past 30 years, Professor Braja M.Das, he has been formulated and researched for the shallow foundation bearing capacity problem with the reinforced geogrid in sand and clay. And also he consideration with the vertical load and also eccentric load. And now, Professor Das will make a short presentation related to the behavior of shallow foundation reinforced by honeycell modular block. I want to invite Professor Das. Let's give him a big hand, okay?
Thank you, Professor Sin. This is a very brief presentation for the behavior of shallow foundation reinforced by honeycell modular block. Over the past several years, many new techniques have been developed to control the elastic settlement of subgrades arising out of the construction of isolated and or combined footings of shallow foundation. These techniques include use of geogrid as a reinforcement in granular fill, use of geocell, and many other things. One of the techniques I saw recently developed is the use of hollow modular concrete block with granular backfill in weak soil. This is called honey cell method by the developer of the technique. This technique was developed by ACE All Company Limited of Seoul, Korea. This is an effective method for substantially reducing the elastic settlement and increasing the bearing capacity of foundations, and hence it is included as a method for use in the construction of in my textbook, Principles of Geotechnical Engineering, 10th edition, with a copyright of the year 2024. Honey cell foundations have been constructed over more than 4 sites in Korea for low and medium high-rise buildings. The highest building is around 23 floors. That is high indeed, with bearing capacity of 600 kilopascals. The cost-effective and simple construction methods that gave tremendously expanded market share of this for the in the Korean market. The following slide shows several components of the construction methods: the foundations, the modular blocks in a group, and the layout of the modular blocks. The procedure of the construction is given in the next slide. It shows that the modular blocks are put together on this ground. The next one is below the modular block. The ground is excavated, compacted, and on that there are several gravel layers placed. The crushed stone is poured on that and it is compacted. The honeycomb cell installation goes over that, and that is being filled with gravel. Over that, there is a very light layer of concrete on which the shallow foundation is constructed. When the load is applied to the foundation, the crust stone in the hollow modulus block, it interacts with the crust stone below it and prevents lateral movement. Once the lateral movement is prevented, the surrounding pressure increases the modulus of elasticity in the vertical direction. With the increase of stiffness in the vertical direction, the result of reducing vertical stress becomes important. Xin, Li, and Yang in 1922 published a paper which studied the bearing capacity and settlement of shallow foundations constructed of honey cell modular blocks in the laboratory model. The failure surface of the foundation, they assumed, for predicting the ultimate bearing capacity is rather complicated, but is shown here. It is essentially a process of a layered soil type failure in the soil. It is somewhat similar to what Professor Meyerhoff-Nahana in 1978 produced for the development of the bearing capacity of shallow foundations on layered soil. The study of Xin et al. In 1922 has indicated that the hollow modular block reinforced by shallow foundations in soft ground is cost effective and easy to construct in the limited area with a less vibration and noise-free technique. Bearing capacity tests results have indicated that at working load, the bearing capacity ratio increases by about 3 times. with the combination force induced by the hollow modular blocks and filled with materials as well as the base of reinforcement. At working load, the reduction of the vertical effective pressure on the subgrade by the confining force of the gravel almost is close to 40%, which is very large number indeed. Further laboratory tests by a second table have shown that the hollow modular block reinforced cellar foundations is effective against dynamic horizontal loading. The following slide shows some of the projects in Korea where the technology has been successfully used, and these are some of the buildings, though not all close. Thank you very much for listening.
Thank you very much, Professor Das, for your excellent presentation. I hope this hornstone reinforcement technology for shallow foundation will be extended in the world, not only Korea and also in America and particularly in the Southeast Asia, where the soft clay is prevailed in the continental. I greatly appreciate Professor Das again for his excellent presentation. Thank you.